A wooden toy is made in the shape of a right cone, joining to a hemisphere so that their circular faces coincide exactly. The cone and the hemisphere are of equal volume. The toy is packaged in the smallest possible closed cylindrical box. What proportion of the capacity of the box is filled by the toy? So for this question, what I would do is first I would mark out the radius, the height. So the the radius of the cylinder equals radius of the cone and equals the radius of the hemispheres. They all are, as you can see. So and suppose the height of the cylinder is h. So we can say r equals radius of cone hemisphere and cylinder. So it's the radius of all the three shapes, and h is the height of the cylinder. H is the height of the cylinder. So therefore, you see, the only other thing I need to point out is this bit is also r. This is the hemisphere, so that's the center, so it will be r. So therefore, height of the cone would be h minus r. So I'm not writing the units here, but you might. It's not very relevant, I thought, but you can always write them. So height of the cone is h minus r, and then so we can work out the volumes now. We know the volume of, so your proportion when they say and the capacity here, so capacity would mean the volume. So volume of the cone equals 1/3 pi r square h times h, which is height. So in this case it is h minus r, and the volume of the hemisphere equals 4/3 pi times r cubed divided by 2, because the hemisphere. So that would mean it is 2/3 pi r cube. Okay, now these two are equal because they have told us that the cone and the hemisphere are of equal volume. So these two are equal. So what we can therefore write is, therefore 1/3 pi r square h minus r equals 2/3 pi r cube. Or you can write 1/3 pi r square h minus 1/3 pi times r cube equals 2/3 pi times r cubed. So what we get is, we can then write 1/3 pi r square h equals 2 plus 1, that is 3, taking this to the right hand side. So we get 3/3 pi r cube. So therefore the 3's get cancelled, pi and r square go, and we are only left with r, pi, h and the 3. So h is equal to, the pi also gets cancelled, sorry, equal to 3r. So this is what we need to write down, H equals 3R. So once we know H equals 3R, so therefore volume of cone would equal 1/3 pi r square times 3r minus r, that is 2r. So it will be 2 out of 3 pi r cube. Okay, and the volume of the hemisphere is 2/3 pi r cube anyway, so it remains what it is. So now we can find out the total volume of the hemisphere and the cone. So volume of hemisphere plus cone, volume of hemisphere plus cone would equal, so 2/3 pi r cube plus 2/3 pi r cube, that is 4 out of 3 pi r cube. Therefore proportion, oh sorry, we need to find the volume. Write down the volume of cylinder equals pi r square h, that is pi r square times 3r, that is 3 pi r cube. Okay, so proportion is volume of cone plus hemisphere divided by volume of cylinder. Okay, so that would equal 4/3 pi r cube divided by 3 pi r cube. So that I can write as, that is equal to 4 out of 3 pi r cube multiplied by 1 out of 3 pi r cube. So all of the pi r cube, the pi and r cube is cancelled, and I'm left with 4 out of 9, which is the answer. So the answer, what proportion of the capacity, that is 4 out of 9. Oh, I can write it here. That is 4 out of 9, and that is the answer.